So consider this given problem statement. So here set A is given as the elements 1, 2, 3 all the way up to 10, and the next set B is given as m by n. So here the elements m by n will exist such that m and n belongs to the set A, and the constraint is given on this one, that m must be strictly less than n, and the GCD, that is the greatest common divisor for this m and n, must be 1. So based on this constraint, we need to enlist all the elements one by one, and then we need to count the number of elements in B. So for this, I'll take a tabular structure, right? And here, so here I will list out the possible values of m, and here whatever valid m will be allowed, I will use those values, because I have to write m in such a way so that m should be strictly less than n, and the GCD and the n and m combination must be such so that their GCD is also 1. So let us try, and here I will maintain the count, that is the number of elements in B. I'll try to maintain the count of that. So first element, if I consider here 1 for m, let's say, so in that case for n I will not be able to take 1, because that is not allowed, because here strictly m must be strictly be less than n. So for n I will start with 2. So in that case the only possible value for m would be 1, and here the count is 1. Next, now for the next one 3. So for this I can write 1 comma 2 such that this both the constraints are allowed. So for this one, this count will be, previous one is 1 and this one is 2, so that is 3. So I'm just writing in a prefix sums structure. Then for the next one, for 4, the allowed values for m would be 1 and 3. So in that case the count becomes, now the last value was 3 plus 2, so that becomes now 5. Now for next number, that is 5. So for 5 the allowed values are 1, 2, 3, 4. So the last one is 5 and here it is 4. So till now the count becomes 9. So we have to manually count this. There is no other way for this one. For 6, only allowed values are 1 and 5. So last value was 9 and this one is 2. So 9 plus 2, that is 11. Okay. Now next, for 7, the allowed values would be 1, 2, 3, 4, 5, 6, because the co-prime combination here, right? So the last value that I calculated is 1, and here 6 values, that is 11 plus 6, that is 17. Now next I'll consider for 8. So for 8 this will be 1, 3, 5, 7. These would be the allowed values. So last value was 17 and here we are adding one extra, that becomes, so the 4 elements here. So 17 plus 4, that is 21. Now next one for 9. So for 9 we'll have these values, that is 1, 2, 4, and then 5, 7, 8. So 1, 2, 1, 2, 4, 5, 7, 8. And the previous was 21 plus 6, that becomes 27. And now finally for 10, the allowed values would be 1, 3, 7, 9. So this becomes 27 plus, that is 4, that is 31. So 31 is the desired answer. 34 is the required answer. So for this one, we'll mention the answer is 31. So there are 31 such elements in this set B, right? So I hope it was easy and straightforward. Thank you.